our trigonometry unit. Lots of different definitions, so homework is really important for this, so you understand the difference between a principal, a terminal, a coterminal, and related acute angles. And then you're also going to start to be able to represent angles on the Cartesian plane. Just remember from our math experience that our quadrants are never going to change. So you're going to label your quadrants with quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and those never change. You never rotate them or anything. So you just need to remember that when we're looking at our angles and whatnot for this unit. Some definitions here. So an angle is formed when a ray is rotated about a fixed point called the vertex. So here would be your vertex down here, and the blue lines would be your rays. So to start, you have your initial arm here, and then it's going to rotate up to wherever it ends for your terminal arm there. Okay, the ray is called the initial arm at the beginning of the angle and the terminal arm at the end of the angle. And just to remember, you've seen probably a lot of these before, but angles are often labeled with Greek letters such as theta, alpha, and beta. I generally use theta. That's theta down there. So you'll see that quite a bit in our unit. More definitions for you. So standard form is when you have a vertex at the origin. So it's going to be right at that 0.00. And the initial arm lies on that positive x-axis. When you get into not standard form, you will notice either the vertex has been moved and it's no longer there at that origin, or another example, that initial arm, this is at the origin, but that initial arm is no longer on our positive x-axis, so it's also not in standard form. To get a positive angle, so sometimes you could be asked to find a positive angle or a negative angle, so you just need to know what is expected for you there. A positive angle is going to be a counterclockwise rotation of the terminal arm. So you're going to have your initial arm here on that x-axis, and then you're going counterclockwise back to get to that terminal arm. That is a positive angle. A negative angle is formed by a clockwise rotation. So here's still your initial arm here, and there is your exact same terminal arm, but if I want a negative angle, you have to go backwards, and you have to go clockwise. Coterminal angles share the same terminal arm and the same initial arm. And then so we're going to go over 4 different examples of coterminal angles. And you will notice that they are the exact same position on your XY plane. They haven't moved. It's just that we can actually label them with 4 different angles that are coterminal to each other. So let's say that for theta 1, it is equal to 120 degrees. Okay, then you know that you have theta 1 as being 120 degrees. You can actually go and get another positive angle by just adding 360 degrees. So go around 360 degrees plus that additional 120 degrees. It has to be a full rotation of 360 degrees to be able to get to that same terminal arm. If not, then you would be somewhere else in your XY plane and it wouldn't be a coterminal angle. So you're going to go 360 degrees plus that 120 degrees is equal to 480 degrees. Okay, so theta 3, we've done the exact same thing, but we've gone around 360 degrees once, and then we're going around it twice. So you can do 360 plus 360 plus 120, or you can just do 720, which is 360 times 2, plus that 120 degrees, and it is equal to 840 degrees. Okay. As well, you could go around another 360 degrees. They will continue to give you more coterminal angles, but here, this one is an example of a negative coterminal angle. So you're actually going to, for our 4th angle, you're going to take your negative 360 degrees because you've gone backwards, and you're going to add that 120 degrees to it. So you should get negative 240. So they can be positive and they can be negative with our principal angle of 120 degrees. So there it says the principal angle is the angle between 0 and 360 degrees, so it will always be positive. And then our coterminal angles 480, 840, and then that negative 240 are all have the same principal angle of 120. Another definition for you is related acute angle. It is the angle that's formed by the terminal arm of an angle in standard position in the x-axis. So it's always, this is really key, with your x-axis. It's never going to be on that y-axis. It's never formed with the y-axis. It's always this x-axis. So for that, in our first example, you have your initial arm, x-axis, and then you have your terminal arm there. This beta in between is going to be your related acute angle. So for the first quadrant, it's actually quite easy because you have your angle that's given, so say 45 degrees is your related acute angle. Where, as in quadrant 2, you have your angle that's given, so say, I don't know, 140 degrees. That is not your related acute angle. Your related acute angle is formed with the terminal arm in standard position and the x-axis. So you actually have to come here to find your terminal arm, and it goes and connects with that x-axis. So where you see that beta, that is your related acute angle there. RAA just stands for related acute angle. It's a short form for you. Okay. Same again. Here is another angle, theta, that's given to you. However, that is not your related acute angle. Remember, it's between that x-axis and your terminal arm. So that is where your beta is, and that is your related acute angle there. Okay, and then same thing for quadrant 4. Again, even if you go backwards or clockwise, your related acute angle is formed between the x-axis and that terminal arm. And just a note, in our book, they talk a lot about reference angle. It means related acute angle, and that's a little bit better terminology, is related acute angle. Okay, so here's an example for you, and it wants you to determine the principal angle and the related acute angle for theta equals negative 225. So to start, we are going to just take a look at this diagram. So your first step would be to draw out that negative 225 degrees. Remember, negative is going to start at that 360 degrees and go backwards. Okay, so backwards to the x-axis would be 180 degrees plus an extra little bit to get that negative 225. Don't worry about it being super accurate. I'm just looking for it to be being in that quadrant, the correct quadrant. Okay, so to determine the principal angle and the related acute angle, it is going to be easiest to find that principal angle first. And remember that principal angle is the smallest positive, oops, there's a little short form for you, angle that is coterminal, to that negative 225 degrees. So if you're looking at that example, you're going to just take that 360 degrees and subtract 225 degrees, which is going to give you 135 degrees. So remember, because it has to be positive, you're basically figuring out what's left over from a full rotation of 360 degrees. You went negative 225, I need to figure out what's positive left there. Okay? And then you're going to look for your related acute angle there. So your related acute angle, remember, it's always with your x-axis. Oops. Okay. And then you're just going to use that principal angle. That is probably your easiest way to do this. And take 180 degrees because it's with the x-axis, so this would be 180 degrees, and you're just going to subtract that 135 degrees, which is your principal angle, to figure out what is left over, so that is 45 degrees. So you're just going to subtract the 180 minus that 135 from there. Okay, so that's example number 1, and that's just going over some of the terminology that you'll have to get used to. Okay, example number 2 is determine 2 consecutive positive coterminal angles and the first negative coterminal angle for 43. Okay, so you're easiest to actually just sketch. So you're going to sketch a positive principal angle of 43 degrees, and now it wants our next 2 consecutive positive coterminal angles, and then we'll worry about that negative one after. So all you're going to do here is you're going to do 360 degrees plus that 43 degrees. Remember, coterminal means that it has to have the exact same terminal arm. Okay, so you can only add or subtract increments of 360 to get a coterminal arm. So then you're going to get 403 degrees there. For our next one, we're going to go around twice. 2 consecutive means back to back. You can't say, oh, Miss Mitchell, I'm going to add 10,080 or sorry, 1,080 to the total. It has to be the next one, so you can only add another increment of 360 degrees. So you're going to go 360 plus 360, or you could do the 720 like I did in the one previous example, and then you're going to get 763 degrees there. And then it wants to be, our first negative coterminal angle. So you have your 43 degrees, but we're going to go backwards to figure out what it is. So you're going to go negative 360, remember going backwards, and then you're going to add that 43 degrees to it. And we're going to get negative 317 degrees for our first negative coterminal angle. So therefore, you would have 403 degrees, 763 degrees, and negative 317 degrees that are coterminal to our principal angle of 43 degrees. Okay? Your homework is on page 2 in your textbook. Just remember to complete all your questions and remember that that reference angle is equal to related acute angle. Just if you're getting confused in your textbook, that it is there. Good luck.